Hey, MathKook here. This video contains one of many examples in my Algebra 2 library. The rest of those examples, along with hundreds of other videos, are only available at mathkook.com. Let's MathKook it up. This question says, graph g of x equals 2x minus 4 all over x squared minus 1 using the domain, asymptotes, x-intercepts, y-intercept, and a t-chart if needed. So let's take a look at the steps for graphing a rational function. So step number 1, we are going to find the domain. Now for a more detailed analysis of finding domain with several examples that I work out, check out lesson number 52. Alright, so let's take a look at our function here. To find domain, we're mainly concerned about the bottom here. We do not want a 0 on the bottom of a fraction because that will make the function undefined. So because of that, we're going to set the bottom equal to 0 and solve for x. So x squared minus 1 equals 0. We can add the 1 over to both sides. The 1's cancel. X squared equals 1. We take the square root of both sides. And x equals, and make sure we remember the plus or minus, because whenever you take the square root of both sides of an equation, we need to write a plus or minus over here. All right, so therefore our function here has restrictions of x is plus or minus 1. So what is our domain then? So our domain cannot equal, so it's all real numbers except plus or minus 1. So I'm going to write a little slash here. So x cannot equal plus or minus 1. So we're going to write our domain in interval notation, negative infinity to negative 1, 1 to 1, and 1 to infinity. All right, so there is our domain. Now let's go to step number 2. Find the vertical asymptotes, horizontal asymptotes, and slant asymptotes. So for a more detailed look at how to find any of these asymptotes, take a look at lessons 83, 84, and 85. I go into much more detail of how to find these asymptotes. So let's start with the vertical asymptote. So to find vertical asymptotes, we set the bottom essentially equal to 0 and solve for x, kind of like we did for the domain. However, we have to be really careful because there could be a hole here. So we're going to factor the top. So if we factor the top, we can take a 2 out. We'll have x minus 2 all over, and the bottom, if you factor the bottom, it's the difference of two squares. It's x minus 1 and then x plus 1. All right, so notice nothing cancels, so we don't have to worry about any holes in this graph. Now the vertical asymptotes are going to come from where the bottom equals 0. So the bottom equals 0 here and here, so we'll go x minus 1 equals 0 and then x plus 1 equals 0. Add 1 to both sides, x equals 1. Subtract 1 to both sides, x equals negative 1. So these are our vertical asymptotes, x equals 1 and x equals negative 1. So I'm going to write those over here. So those are our two vertical asymptotes. All right, the next asymptote is a horizontal asymptote. So let's go ahead and erase some of this work here. So for horizontal asymptote, we compare the largest exponent on top to the largest exponent on the bottom. Now in this case, there you have an x to the 1, so I'll write a 1 here. And then on the bottom, we have an x squared. So notice this function is bottom heavy, meaning that the larger exponent is on the bottom as compared to the top. So whenever a function is bottom heavy, the horizontal asymptote is automatically y equals 0. So I'll write that over here. So y equals 0 is our horizontal asymptote. Now, if we have a horizontal asymptote, there is not going to be a slant asymptote. You can't have both. You can only have one or the other, either a horizontal asymptote or a slant asymptote. All right, next we're going to find the x and y intercepts. So let's go ahead and erase our work here. How do you find an x-intercept? Well, you plug in 0 for y and solve for x. So here's our starting step for finding an x-intercept. You plug in 0 for y. like I've done here, and we'll solve for x. So I'm going to get rid of the fraction. I'm going to multiply both sides by x squared minus 1 here to eliminate our fraction. So on the left side, we have 0 times this, which is just 0. And on the right side, we have x squared minus 1 canceling with our x squared minus 1. So we're left with 2x minus 4. All right, so now we need to solve for x. We move the 4 over. So we add 4 to both sides, and then we divide by 2, so x equals 2. Now we want to write this x-intercept as a point, so it's going to be 2, 0, because every x-intercept has a y value of 0. All right, so there is our x-intercept there. So 2, 0, so we'll write that here. And then remember we said there was no slant asymptote because there's a horizontal, so here I'll write none. All right, so that is our x-intercept. Now let's find our y-intercept. So to find the y-intercept, we plug in 0 for x and solve for y. So wherever we see an x, we'll plug in 0. So here's another x, we'll plug in 0 squared minus 1. All right, so we have 2 times 0, which is 0, minus 4. So on top, we get negative 4. And on the bottom, we have 0 squared is 0, minus 1 is minus 1. Negative 4 over negative 1 equals 4. So our y-intercept is 0, 4. Every y-intercept has an x value of 0. All right, so we'll write that over here for our y-intercepts here. So 0, 4. All right, so now we have found all the information they've asked us for. And let's go ahead and do step number 4, make a t-chart and plug in x values to get a better idea of where the graph goes. And then number 5, we're going to put information together in graph. So let's go ahead and erase this along with our chart here. So I'm going to bring up our graph. Let's go ahead and start graphing our asymptotes and our intercepts. So our vertical asymptote is x equals 1 and negative 1. So we're going to go through 1 here and negative 1 and draw our vertical asymptotes. All right, so those are our vertical asymptotes. I'm going to go ahead and label those. So this one here is x equals negative 1, and this one over here is x equals positive 1. Next, our horizontal asymptote is y equals 0. So go ahead and graph that. Then over here on the right, there it is. Okay, and we'll go ahead and label that one as well. So that one, so that horizontal asymptote is y equals 0. All right, next we are going to graph our x-intercept, which is 2, 0. So we go right 2, so it's right there. Put our dot there, and then our y-intercept is 0, 4. So we go right 0 and up 4, which is right here. Okay, so we definitely need some help to graph this because we have no idea what it looks like on the left here. It could be down or it could be up here. And in the middle, there's 4 options between 2 vertical asymptotes. It could be a squiggly like this, a squiggly like this, a parabola kind of up here, or a parabola down. And then on the right here, we have something interesting. We have this point here that's sitting on the horizontal asymptote. So that means it's going to cross through and come back, either like that or like this. So we want to plug in a bunch of values. So let's make a t-chart here. And we're going to plug in values in each of these regions I mentioned. So we're going to plug in negative 2. So we want to be strategic about what x values we plug in. Negative 2, I'm going to plug in negative 1/2, positive 1/2, 0 also, of positive 1/2, 1.5, and then 3. All right, so we get some values in each of these areas here that will help us round out the graph. So I'm going to go ahead and plug in -2. Over here, we'll plug it in kind of small here. So if I plug in -2 for x, so wherever I see an x, I plug in -2. So the top is -4 minus 4, so that'll be -8. And the bottom is 4, -2 squared is 4 minus 1, which is 3. All right, so that's our y value, -8/3. We'll put that here. So -8/3. All right, so let's go ahead and erase that work. Now, rather than plug in all these and kind of just use up a bunch of time on the video, I'm just going to tell you what these values are. I've plugged these in my own time. So plug in -1/2, you get 20/3. Plug in 0, we know that one is 4. That's just the y-intercept. Plug in 1/2, you also get 4. Then -4/5. Plug in 3, you get 1/4. All right, so these are all our points here. And let's go ahead and graph them. So -2, so we're going to go left 2 and then down 8/3, which is about 2 2/3. So that's about right there, almost at 3. So that's like right there. All right, next is the point -1/2, 20/3. Okay, so -1/2 is right about right here, and then 20/3 is about 6 1/3. So that's going to be like right there. Next we have 0/4, which is right there. 1/2 4, so 1/2 4 is right there. So it's right next to it, which is kind of odd. We'll talk about that in a second. Now 3 and 1/4, so we go right 3, up 1/4, so that's like right there. Okay, sweet. So let's go ahead and graph this. On the left here, since there's a point here, this graph must look like this here. So we'll go ahead and graph that. And then in the middle here, we have this graph here. So we know it's going up here. It's going to come through, and it looks like it's coming back up. So it looks like it's kind of parabolic here. So it looks like it's going to look like this here, and then kind of come back and go up forever. All right. And then on the right here, it looks like it's going to come up here, go through these 2 points, and then come back, because it has to approach this horizontal asymptote as x goes to the right forever. It cannot go up off into nowhere. It has to approach it. So that means it's going to look likely like this here, come through, and then come back. All right. So there is our graph of g of x here in blue. Hey Kook, if you found this video helpful, hit that like button, subscribe, and drop a comment. For unlimited access to all of my Algebra 2 videos, visit mathkook.com. Thanks for watching.